Taya's not here, so I'm going to record it as well, in case, just in case. So this is example 7. We're continuing on with our lecture. It's called substitution, and now we are going to go into definite integrals as opposed to indefinite integrals, which means we have values. We have a lower limit and an upper limit. These guys will have to become numbers for us, right? Eventually, it's just a number. So are we good there? Cool. All right, so we start off the problem already here. We're going from 0 to 4 of that equation, which we've seen before. So get your math juices flowing, or last week's Wednesday class. I think we have to do is we have to put a 2 out of 2 or 2 over 2 over here. Is that right?
Yeah.
We're going to have to somehow get that little 2 dx inside here. So there's that. And then now we can go, 1/2 now. And I'm going to slide that 2 on top. I'm going to slide it all the way to this side over here. So I got 2 dx. Dun, da, da, da. Done. Can I substitute now?
Yeah.
Absolutely. Let's go with it. Now it's going to be 0 to 4. du. Okay, square root of u du now, right?
Yeah.
Love it. Okay, so let's take the antiderivative of this here. So off to the side, we say the square root of u is equal to u to the 1/2. And then antiderivative of this guy would become u to the 3/2. Perfect. Divided by 3/2, right? Which just becomes and then plus, take on a little plus, right? That's what we do in our mind. So I'm going to put this little bubble, the Garfield bubble. Boom.
Because we're saying that to take the derivative of 2u to the 3/2 over 3 would equal u to the 1/2. Wait.
U to the 1/2,
Okay.
Because the 3/2 is going to multiply the 2/2, they will cancel each other out.
Yeah.
And then we're going to subtract 2 out of 2 from 3 out of 2.
Which gives you 1/2.
Which gives you 1/2, which gives you a
I'm
square
not
root.
very good yet at recognizing those just off of that.
Mm-hmm.
What?
Yeah, and then on page, what is it, 392? Is that the page? We have all the rules. Yeah, if you need to go back to it, just kind of to look at some stuff, 392 is a good page to have as a reference sitting there as you're doing these stuff. Okay, I think we're good to go here. So this is 1/2. Oh, 1/2 is still on the outside. So I got a multiplier here of 2, u to the 3/2, 3. Evaluated, oh, no, can't do evaluation yet. I guess we can. We can put them in as 0 to 4, right? But we're not evaluating u, we're evaluating x. That's no fun.
We can take away the 2 and then put in the 2.
Awesome, yep. 2's are gone. That's cool. And let's put the x back in. So 2x plus 1 to the 3/2.
When does the du disappear? Well, I know it just disappeared, but
When we took the antiderivative, when this integral symbol disappeared,
away.
that disappeared.
Okay.
When we took the antiderivative. Cool, all yours to put it in here. And let's see, 4 goes in there, that's 9.
Yeah.
9 to the 3/2 divided by 3 minus 0 plugs in there, but that's still a 1, right? 0 plugs into here. That's still 1 to the 3/2 minus 3. And you follow, ask me the questions and follow along, right? So we plugged in the 4 into here. That made 4 times 3 is 8, plus 1 more is 9. Now we got to figure this out here. So let's see, square root of 9.
So that's 3 times 3 cubed.
Yep, that's 3. Square root of 9 is 3. 3 to the third power. 27?
Yeah.
27, but then it's still divided by 3. We'll just keep that there just in case we need it.
Subtracting of it.
Yeah, we're going to be subtracting. So square root of 1 and 1 to the third power.
Where does the 1 come from?
It's
Uh-huh.
1
The 0 plugged into here. And then we still have that little extra. So 2 times 0 plus 1.
Okay.
Okay, talk to me. Everybody okay with where things came from? Enrique? Now Enrique's a little quiet, so I'm not sure what's going on.
I'm just still remembering chapter 5 thing.
Okay,
After getting the first in chapters 3 and 4.
that's true, yeah. So you have to come out of that here, and which is a different process entirely, right? 26 over 3? Are we good with 26 over 3? Okay.
Yeah, wait, remind me how we got rid of the exponent by the 9.
9, yeah, absolutely. So it's right over here. It's the square root of 9 would be 3.
Uh-huh.
So then it'd be 3 to the third power. 3 times 3 times 3. Done. Are we? I think we're good. Now the fun little stuff here. So wait a minute. That's a lot of work. I wonder if I could shorten this out just a little bit. So let's do, and Eli, talk to us, okay? Just in case if you ever need to. I'm gonna go with example 6. Let's do it over again. Let's just see how we can make this a little bit faster.
What's the
Same exact process, same exact example here. Now, do we have to do it the short way? No. You could do it the long way, you could do it the short way, just like long division and short division.
how would you ever do long?
Just to make sure you're right.
You don't know how short the
Yeah, do you guys know short division? If there's a long division, it has to be short division, right?
Short division's called, let's not do problems that have weird numbers in them.
your short division is called mental math.
Twelve divided by
Real
3.
quick here, just here's a short division. Right? So you say 3 goes into 4 how many times? Once. Leftover. And that little 1 right there becomes the 10th digit of the number
Yeah.
back. Or you could put it either there or you could put it here, whichever way you like it. But then you go 3 into 15, 5. 3 into 3, I should have made this into like a 7 or something. 3 into 7, twice, right? And 15, remainder 2. There's your short division process. Or long
We're
division.
going
of,
back to algebra, you guys. No, that's still long. I
It's like
still don't
Still
like
too
that.
long.
Same thing, but just
Short
you're not
division is
writing out.
tough.
You're not going all the way down the page.
Correct, yeah, you're not showing all your steps.
It's better than polynomial long division though.
Oh,
That's
God.
not fun.
Uh-huh.
It's like long division,
Never-
but you have other stuff involved.
I have never thought about polynomial long division since learning about it.
Since when?
Okay,
Like
let's
algebra,
jam.
Pre-algebra or algebra. Never
No, we did algebra 2, I think. Wait, isn't it algebra 2?
I think. you
Oh, no,
did
the division
pre-algebra.
algebra 2. You may have seen in algebra 1, maybe.
I don't think so though,
I
because
was tutoring somebody in algebra 1 and they had to take it.
Uh-huh.
They had no idea.
Yeah, it's
I
the
would
tail
have
end.
it.
I can't help you. Let's
No.
talk about the quadratic formula.
So we have, it starts off exactly the same. So far we define u, we define du, everything's great and peachy. And then we have to get the 2 over 2 still in front. Everything's still cool. we have to figure out how to set this up so 1/2 comes in. Now 2, sorry. And this is the extra little step. A little bit of work ahead of time, but it may save us some time afterwards. It may save us a lot of time afterwards. Let's see. So as we substitute things in, let's put the 1/2 down. And let's also substitute the limits as well. Because these are in terms of x's, aren't they? That's x, that's a begin x, that's an end x.
Yeah.
So how about this? I'm going to just plug in the 0 into this little u function. That gets me a 1. I'm going to plug in a 4 to the u function. That gets me a 9, I believe, right? I think I've seen 1 and 9 before somewhere. Now this becomes du, or sorry, square root of u du. Okay, talk to me. Everybody okay there? Simple little trick. May save us some extra time later on down the road,
So
especially when things are really complicated later on.
now is our 9 and 1 in terms of u?
Absolutely.
Yeah, so
Now that's a beginning u and an ending u limit. Let's take the antiderivative. Let's jam. So this will be, again, same exact process, right? Multiplied by u to the 1/2 becomes u to the 3/2. Divide by that, multiply by that, evaluated from 1 to 9. Twos cancel out. So u to the 3/2 over 3, evaluated from 1 to 9. And you should see these same numbers.
Yeah, after that, it's just the same.
Same numbers will come in on
You
themselves.
just
here.
have to
So-
remember that when you're doing it that way, you don't put the 2x plus 1 back in.
Correct.
If you're doing it the other way, you need to make sure to do it, because I feel like that could be something you would mess up. If you weren't paying attention.
You just put the variable back in there.
Yeah, that, like, definitely.
You do all that work to take the variable out, and it's like, yeah, stick x back in there. Because
Okay, are we good? We good? Kate, you good there?
Yeah.
That one? So you choose to decide whether you want to change up the limits or not. That's it. It's all the same though.
But I guess it goes in a lot faster because you're just doing
You're
u as
plugging
opposed
it
to
in.
square root of 2x. plus 1.
And as u becomes more complicated, you don't, you want to be like, okay, now I gotta plug it in, now I gotta, so it gets a little hairy at the end.
Plugging it in beforehand.
I don't know why you do a definite integral anyways. I
So
like
get
the
to-
ones that go to, I don't like the definite ones. I think it's more fun when you don't have to plug stuff in at the end. You can just leave it.
Okay, all yours for practice. Go for it. Give you guys a few minutes here. Try it yourself. Talk among yourselves if need be.
Yeah. Oh, no. Not used to seeing it.
That's what I wanted to
It's just
show you
negative,
guys there.
negative, we're negative second half.
get started as well here. All right, I got almost to the substitution step. And actually, we're going to decide here. So majority wins here. Did you or do you plan to change the change your limits? How about
Change the limits. Yeah.
change the limit? Change the limit. Change the limit. Okay. So let's jam with it here. So -1/5. Eli, give you a vote here too, but
You already lost.
yes. Okay. He goes change the yeah. It's 4 against 1 if you vote against. Okay, so how about junk? Negative? Ooh,
-7, -2.
-7 on top, -2 on the bottom?
Yeah.
Whoa, okay. 1 over u squared.
Okay. I did the
Du. Okay, question?
I just put du over u squared, which is the same, but it made
Yeah.
me get stuck because I couldn't do that.
Gotcha, yeah. I like to put the du all the way at the end because then I know exactly what the function is. So then at this point, I'm thinking to myself, let's see. U to the -2, that's the function I have. So again, add 1 to the exponent, divide by that exponent.
Yeah, so negative one, divided by
-1? Do I have a -1? Evaluated from -2 to -7. And let's get rid of stuff here.
And is that just one of our rules?
Yeah, this is the power rule that says, here's du. It's going to be, we should put
Oh, I
x,
see it.
x to the n plus 1 divided by n plus 1. Undoing the rules for derivatives, power rule for derivatives. Okay, so I got negative, negative, turns out to be a positive, and see if this makes sense. I think I have it like this. Is that true?
Yeah.
The u goes down to the bottom because the negative exponent. And the two negatives cancel each other out, and the 5 is on the bottom.
Yeah, that makes sense when you explain it.
Wait, what happened to the c?
For which one?
Like our rule?
Oh yeah, the little c right here.
Yeah,
Because it's a definite integral,
you don't need that.
we don't need it because it's going to cancel off anyways. All right, I got myself, let's see, negative, the -7 going into there. This would get crazy, right? If we had to put the rest of it back in.
Yeah.
I like this substitution method. So the -7 comes into here. And so I'm gonna put the negative on the outside, subtracting off a -2. So that'd be what, -1/10?
Okay, so you put it. I guess, for me, how do you determine if you put the -2 or the -7?
Yeah, always, 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 it goes top first, subtract bottom.
Oh, okay.
Huh. Order of operations with anti-derivatives. Great. So left to right, top to bottom.
Mm-hmm.
Cool. Are there parentheses for antiderivatives as well?
If you have a
It'd be like if
string.
the bottom derivative is squared, you gotta put that one first.
Yeah. But if you have a string of them, could you imagine if you had
Antiderivative of an antiderivative.
Can you,
Instead of having negative
Can you
7, it's
go
just another
farther?
antiderivative.
that's the real question, can you
well,
go,
yeah, you could do double antiderivatives.
Yeah, so what is that?
You could do triple.
like a, taking the derivative twice and
Uh-huh.
whatever, so what would it be?
You just have something that looks like this.
If you get 7 over
Yeah, so
90,
what is that though?
So you go from the inside to the outside, right? Just like you do order of operations, go from a parenthesis sort of.
I don't like that.
I don't like that.
Well, what,
Right.
so you have area, and then what do you have?
If you go
Area?
to, uh-huh.
Or superior area, the area of the area, the instantaneous, what?
The instantaneous area?
The
No, 'cause once-
instantaneous area. Don't you know theoretical physics, Kate?
Oh, my bad.
Rate at which the rate of the rate.
The rate, which the rate of the area. You know, because that, it's the wrong direction, what is it?
No, if we do it sequentially, so when we do this right here, it's a triple integral, we usually look at dimensions at that point. We think about them as, you can think about it as an acceleration going to velocity going to position. But normally we say is x coordinate, y coordinate, and z coordinate.
Acceleration to velocity and then.
Yes, sorry. What did I say?
Oh.
That's,
Well, no, you were talking about for derivative.
Yeah,
Oh,
because
okay,
it's
got
not,
it.
For integrals, you go from acceleration to velocity.
but it's
Uh-huh.
not the same thing, you can't think about it that way, because it's not the same.
But that's wonky.
Derivatives is going one way, and or integrals is going the other way, and they don't cross.
Oh, no, they do,
Sure.
in this way, if you're going from position to velocity to acceleration, yes, they do cross. You go one
But
back
it's not
together.
the same as taking the.
Your starting point is different.
It's not this, yeah, the starting point is different. It's not the
Yeah.
same as the integral of the,
Correct.
of the position.
If you go this way, you're taking derivatives. You can't go from position to go that way.
Right.
Doesn't make sense. But if you start out acceleration, then you go backwards to position.
Yeah.
Yes.
You could use
Right. I mean, you could.
What do we get for the answer, first of all?
I got
I don't
114.
wanna
Yeah.
simplify that.
I got something over 90 first.
Says to the theorist in the class, like, why do I need to deal with the numbers?
That's why I don't like
I got something
integrals.
over
I don't
90
want to
because I
plug
thought
in
that,
numbers. Numbers are
7
bad.
times 5 was 45.
Oh.
Nothing. It's embarrassing, okay? I don't want to talk about it.
Let's see, I made common denominator 70. Are we good with 70?
Yeah, I got 1 over 14.
1 over 14?
When it's like, because then it's 5 over 70,
Okay, uh-huh,
and then I simplified that down to 1 over 14.
by 5, right?
Yeah.
Okay, gotcha. 5 over 17.
Oh, wait.
Positive.
No, 1 over 14, right?
1 over 14? 1 over 14.
What?
Yeah.
5 over 70 divided by 5.
What?
Is 1 over 14.
Eli, are you doing good over there?
Yeah.
Yeah.
We're trying to do
Because 15.
I don't
elementary
know.
fractions
I
here.
don't
Hold on.
care.
Just wait for us.
We can't do fractions.
1/14?
1/14.
1/14. Okay. Now we are good. Okay.
Same as Eli, you're tutoring your brother in fractions, right? Oh wait, what is he doing now? Is he doing geometry?
He started algebra. It's great.
Uh-huh. Okay, we're good.
Not geometry.
Let's see. Let's throw in ln or e function. Let's see how much time we have. Of course, we got to throw that in.
I
10.
thought it was fun.
Is this all part of, what is this, 5.5?
5.5, yeah.
I like do the early stuff like that, and then it's like, oh, this is actually kind of enjoyable. And you get to like, you know, 1 and e and exponents, and it's like,
And then it doesn't.
At Cold Poly though,
Sorry.
they don't do early transitions. So.
Yes, we are ahead of the curve.
Sneaky, sneaky.
You guys will go and do derivatives of exponential logarithm function. You're like, I already know this. Come on.
Yeah.
Hopefully. I kind of doubt it.
What was our rule?
I can do ln of x. I can't do like the really, really, really complicated.
Let's see.
Okay,
What is ln of x?
I'm just really amazed. Wait, 1 over x?
Yeah.
Yeah.
Okay,
so what is u?
So
Yeah, what is u? So we got a choice. U could be ln of x or u could be x. Which one would you guys like?
X.
Well, wouldn't ln of x save us problems down the road?
How on earth is gonna be better?
Yeah. Oh, hold on. Let's see. If you do u is equal to x, do you gain anything by that?
Yeah.
No. So there's no point of actually even doing u is equal to x ever. Even though it looks, even though it's easy.
It's easy now, it's hard later.
So du is 1 over x.
Okay, u would have to be ln of x. And what is du?
1 over x.
1 over x
And
dx.
look, it's already
Oh,
there.
nice.
Hooray! U times
Okay. Eli, are we good there?
du.
It fit
Yeah.
nicely for us. Okay, so then,
I don't think we can count on this.
This is suspicious.
I expect.
Well, this problem's easy. The next one, example 11 is
The
probably
next
terrible.
one.
11 is just a bad number in
Yeah.
general.
Okay. So,
Alright.
wait, do we want to plug in?
all yours here. That's, oh, sorry, that's up to you guys. That's, again, it's which way do you want to go?
I think we should maybe change it.
I like that
Well,
one.
no, actually, this is just on the x over x. That's probably not too hard.
It's not too hard. Yeah, this
Yeah.
one, but if you want to. Kate says yes. Sadie says no.
I've already done it.
Changed or not changed?
I changed.
Changed 2 to 1. Christopher,
Technically,
say don't change, don't change, don't change.
Yeah, don't change.
Don't change, it's a tie. Eli, you gotta break the tie. Change or no change?
don't change. You like too much work.
No change.
Change or no change?
Change.
No change. It's a no change.
Aha, you gotta do it over again, Enrique.
Too late for me.
Oh,
I already changed it. I gotta make a habit out of doing it. Otherwise, I won't do it on the test, and then I'll take way too long.
Granted, yep. Okay, so if you do this here, so again, Kate, here's your power rule, right? So this is a 1 technically. So I'm gonna go add 1 makes it 2, divide by 2.
So you're gonna do something in the power.
Because there's a power of 1 there, right?
Yeah.
So add 1 to 1 makes it 2, divide by 2.
I don't like this.
I know,
but
and that part
okay.
just doesn't like,
So
in my
if we
brain
ever
isn't-
get a 0, it's real
Period.
easy no matter what.
I still have to remember the answer to this.
Uh-huh.
Let's put down as the.
Yes, uh-huh. And I
There's
had the
like
same
7
issue when I was
billion
learning it
things
as
I could
well.
write.
I stared at like the uses of like, wait a minute. If I take the derivative of this, it's just gonna be 1. Wait a minute, how am I supposed
E
to
is
do this?
1, right?
Yeah.
And
but
then ln of
what's
1,
ln of 1?
e to the what equals 1, well, e to the 0, right?
What's ln of 1?
It's 0.
Ah,
Is
Yeah.
it?
Yeah, because e to the what equals 1. Zero.
I think
Ellen function, this is,
0 over 2 is just 1/2.
Wait,
Take that traditional way.
Don't
isn't there
start
another?
this.
Oh, no, no, no.
I squared it already though, but yeah.
Conservative
1/2.
Mhm.
What is this?
Now we're doing example 11.
Examples 11, of course.
Example 11 is terrible.
I'm deciding what example 11 should look
Make
like.
it really terrible.
Don't make it really terrible.
We
No, wait, go back.
Make it horrible for the conservative calculus.
Wait, go back. We're still counting it down.
Sorry, good, good.
I think my problem is
Very
important.
I did it and then I erased it.
Oh, no, my problem is.
You're using a pencil. Wow.
Wait, are we all using pencils?
You made fun of me for using a pen. Jeez.
Wait, Enrique, is that a pen?
I used it on my test.
Oh, you use a pen on your test?
Well,
He's
so,
that
You
confident.
have confidence?
I would
No,
Imagine.
I wrote like
Good,
for what I
Christopher?
did wrong.
Oh, okay.
Example 11.
Action.
Wonder. Okay. Let's see. We have still a little bit of time.
Wait, are we almost done? Like, are we done with this section and comes to the concepts?
One more concept, but I want to just practice a little bit more with you guys on this.
Is that a e to the x negative x squared? Oh.
Oh, I hate that.
So then u is gonna be negative x squared, or u e to the negative x?
I don't know.
I think we'll use, or would we?
You would
Well, let's see.
I think this is
U
one of those
of e
problems
to
I
the
get a
negative
one
x
on.
squared wouldn't help.
I
Would it?
I mean, we have that x there.
To the negative x squared.
If we make it negative x squared, then we can do the derivative being 2x, and then we'll just need to pull a 2n, which is, we already have that x there. That seems nice.
Yeah, because you have kind of two different functions. Yeah, this one
Yeah.
possibility is all of this e to the da da da, but
I
then
think
you're
we should
stuck because you have
just do a little bit.
Yeah, because I don't
Or
think
just
u to
this
the
piece.
x is gonna do anything, or
e to the
e to the, yeah.
So u is negative
2x
x,
would be zero.
negative x squared, right?
negative 2.
Yeah.
Yeah.
Okay.
Oh,
E is equal to negative x squared. See what happens.
Oh, we just got to, oh.
oh wait, negative 2. So would we have to multiply by negative 2x over negative 2x? No, we wouldn't. Wait. I'm so confused.
Go ahead, Kate. Talk us through
It's
it.
okay.
No, okay. So du, let's do du first. Du is a negative 2x.
Negative 2x dx.
dx. Okay, perfect. So
So
dx
would
is
we
there
need to multiply by negative 2?
over negative
Oh,
2.
Yeah, okay, I wasn't totally wrong. I just,
You were there, yeah. That's why I wanted to talk through it because you were there. Okay, that one's there. I'm gonna move the x to the end. So x goes over here, dx. I could put it inside a little parenthesis now. And now I have myself a negative 1/2 on the outside. E to the negative x. And then I got a negative 2x dx. Okay, Eli, are we good there?
We should change the one.
Mhm.
Okay, limit change or no change?
Yes.
Well, I mean, it seems like it'd be easier, would it?
Yeah, I think
Yeah,
so.
it
Bruh.
What, you don't like my political?
Would it be-
metaphor?
I got peer pressure.
Well, let's see, just for a little bit of work, I think it makes it a lot simple. So 0 plugged into there, right? And then it goes to -1 this
Yeah.
time. How interesting,
Doesn't
okay.
that mean it goes from -1 to 0? Shouldn't we change the top and the bottom?
Wow, that is interesting. Look at that. Now the 0 is on the bottom, negative is on the top.
this is awkward. This is super awkward.
And we don't change them because now it's just computational stuff. That's happening, that's all.
Oh, we still subtract?
Mhm.
Okay.
Okay, so that's u, the e to the u.
Okay. Antiderivative of e to the u is
U, e to the u plus 1 over u.
not a power rule, no.
Oh,
It's just e to the u.
Because, oh yeah, e to the x is e to the x.
Uh-huh.
yeah.
So e to the u is just
E to the
e
u.
to the u.
Okay, so that definitely makes it easier to have.
-1. Okay, so that little -1/2. Question is, we can leave this on the outside for now, or we can bring it in. It doesn't matter. You can bring it in as part of the multiplication each time, or as just a multiplier on the outside at the end. So let me show it two different ways here, just so you guys can see it here. So first things first is leaving the 1/2 on the outside completely. So it becomes e to the -1 minus e to the 0. Are we good with that one?
And then just divided by -2. Or,
At the end of it all.
Yeah.
yeah, I think that would be a little bit easier.
Easier?
You don't have to do it separately.
Yeah.
Or you can plug in the 1/2 each time that you do this. So
Or I
it's-
But you're not
Not,
plugging
just
it
do
in
it at
very
the
hard.
end.
Like, it's not very hard to plug it in. So
Uh-huh.
it seems like you can just do it like.
E to
as
the
a-
negative
Nah, I'm
1.
good. I'm just
It
gonna
doesn't,
put,
I mean, it's
minus-
still easy, either -1 and either the 0. Those
well,
don't.
yeah, but this is the simple part. Imagine that being like
In a more complicated problem.
a more
you can have
complicated
that
problem, just in principle, just divide by -2 later.
outside. Yeah, but right now it doesn't matter because it's so
Mm-hmm.
easy. It's like, well, what's the point? There's no point arguing about it.
Mhm.
It's just state.
Gotcha. Okay. Very good there.
Yeah.
All right. And final answer.
So,
-0.
what are you doing? Isn't it either -1 is not negative, wait, do we
True.
put that on the bottom? Or do we do
E to the
negative
neg-
E?
E is an e to the negative
Well,
1,
e
1 over
to the 0
E?
is 1, so we
Yeah.
gotta subtract that from e to the -1.
E to the 0 is 1.
Yeah.
So then we have -1, but we have a positive, so we're adding 1/2. Right?
I think so, yeah. Multiplying through here, this becomes a negative 1 over 2e. Is that right? Multiplying in here makes a adding 1/2.
Where are you writing?
Could it be here?
Oh. Yeah,
Oh.
yeah, that's right.
Which will be the same thing over here. So the negative 1 over 2 to the
Wait,
e,
why are
and this
we-
would have been plus 1/2.
Why are we doing that now instead of just dividing it by -2?
It doesn't matter, just,
It
so.
does matter. It makes it much worse.
Where, Christopher?
I am going to minus
Why would you
-1 over
why would
E
you calculate
minus,
both of those instead of just smashing them together and then dividing it by 2?
it's the same difference.
Yeah, it's the same difference, but you have to go through like 5 more steps.
No, you don't.
Yeah, you do.
I'm gonna let them argue.
You do.
Okay, so one more last concept here to go through is, and it's just let's do that here. Let's go with symmetry.
Oh, no.
Maybe.
No, I don't want to draw.
So first of all, you guys remember what are the 2 types of symmetry we have?
The ones
With
from both
functions.
sides.
Wait,
the
so,
same.
like one's across the x-axis and one across the y-axis?
Ooh, okay, hold on. So we have symmetry about the y-axis, and it sort of looks like this. This would be a good one. X squared would be a good one.
Yeah. And then there's also like.
Didn't we call it, hold on real quick, didn't we call it an even function? Remember that?
Oh.
This was called
yeah,
an even
we
function.
definitely- I remember that.
Because it went across. Do you guys remember the other one?
I'm guessing the other one is odd.
Yeah, the other type of symmetry.
Well, if it's across the x-axis.
Ooh, yeah, hold on. If it's across the x-axis, that is not symmetrical, right? Because that's not even a function, right?
No, we
Yeah.
had the
Oh, the
odd one, so
origin?
there was-
Can be
Is it the
x.
origin?
Yes, the origin.
I
So
remember math.
symmetry across the origin. Okay, origin looks like this then. X cubed, or the cube root of x is usually, oh yeah, x cubed would be good. So that's the typical function that we use, that we think about. So f of x is equal to x cubed.
Mhm.
Good there? Oh, yes, okay, that's an odd function. Okay, that's cool. Is there, that would be considered odd function. Y is equal to x.
Oh,
No, but
if
like
it's symmetrical
symmetry
about the
about
line.
that line. Do we care about that at all or no?
Okay, fine.
I mean, well, you can have
Symmetry
symmetry
about-
Oh, anything,
over, like-
anything for you?
The
Anything?
y-axis.
Well, I've just heard of that before.
Well, we
Oh, sorry,
can-
sorry. I didn't catch his, so symmetry about this right here, right?
Yeah.
Oh, gotcha. Yes, that is called the inverse functions.
Ah,
Inverse functions have symmetry about the y, about the line like that. but not associated with this lecture today. Just as the answer to Enrique. Enrique answer.
I wasn't going crazy, but it was,
Oh, that is a thing. Okay, let's jump to it. 4 minutes left here. Let's jump to thinking about calculus. So hold on. So think about area. So if I go here, let's say I start off with negative A, and I go to positive A, and I'm trying to do this. From negative A to A, f of x dx can give me any other thing that could again?
like, if you find the area on one side.
Oh yeah, hold on.
Another area on the other.
Yeah, symmetrical. So how do I write that in terms of this? What's your limits, first of all?
You got A, you got negative A.
I'm gonna go,
Oh, God.
I'm gonna go,
Math limit, not.
sorry, I'm gonna go 0 to A. If I'm gonna just do one side, right? If I'm just doing this,
Okay, yeah.
still my same function still exists, right? And what do I have to do? It's gonna be a multiplier. Multiplier by how much? By 2, yeah, so
Okay, what
this.
am I doing right now?
So just two things, two ideas that come out of symmetry from algebra. And so what we're doing is we're placing a view of calculus on top of it. And it just two things that come out of it. And here's the two. If we're talking about area underneath a curve, right here, right? Instead of going from negative A all the way to A, we have this little idea like, hey, you know what?
If it's, you just, yeah, okay.
We can take half of it, right?
Yeah.
If you double this area, you're going to get the other side as well. That's cool. So there's a little right there. It only works for even functions. We're good. So kind of careful there with even functions. That's, again, an idea that pops out of symmetry from algebra. Okay, odd functions here. So I'm going to go like this. I'm going to go, I need from negative A to positive A. Absolutely. Integral from negative A to A of f of x dx is equal to 0 if it is an odd function. So
How come it's not 0 for the other one?
because it's on top, it's above
Oh,
the
above the
x-axis.
x-axis.
That one's below, so therefore they're going to undo each other's work. Okay, and I'll think of a good homework problem that will sort of etch that in.
So do we have more homework for 5.5?
Yeah,
Okay.
yeah, I'll give you guys a homework sheet now, and I am done.
Because you already gave us the first part of what we have, but
Mhm.
we're going to do more for these.
Yeah, yeah, I only gave you guys homework of the indefinite integral. So now we're going to jump to a definite integral. Eli, we are done. We're good. So glad for you to join us. So we will go from there. So test corrections due. Eli, I'll send you I'll scan yours and I'll send it to you. I'm gonna be back home. I scan it so that I can send it to you so I can get home. Cool. Okay. Enjoy the rest of your day.
Thank you, you too.
Thanks. And you guys enjoy the rest of your day too.
Thank you.